The Arc Junkies Podcast is brought to you by my good friends at Rockmount Research and Alloys. These guys have the tools and filler metals to help you all get the toughest repair done right the first time every time. If you've been in the welding game long enough, you've no doubt seen common reoccurring repairs. The problem most people run into with maintenance welding is they try to use rods and wires meant for initial fabrication on clean new material in a shop environment. But that's not where most of these repairs are taking place. It's usually out in the field, in the elements, on equipment that's covered with paint, oils, grease, and other hydrocarbons. Probably the most undesirable conditions to weld in. Now you can whip out your trusty 7018 and lay down some goobers to get that piece of equipment temporarily back up and going until it breaks again, or you can grab a Brutus electrode from Rockmount that's built for this exact situation. It'll burn right over hydrocarbons and provide a weld with higher tensile strength, more elongation, and less heat input to make a repair that lasts. Check out rockmountwelding.com and see their full arsenal of products to help you tackle your toughest welding issue. And if you pick up any of their bits, burrs, or abrasives, make sure to use ArcJunkies10 at checkout and save 10% on your order. That's rockmountwelding.com. We're also brought to you by Outlaw Leather. Are you looking for a new hood? You want something a little bit more custom than what's on the shelf at your local supplier? Need a hood that fits your personality? Then check out my buddies at Outlaw Leather. They make badass custom hoods. If you can dream it up or sketch it out, they can put it on a hood. They also have stock hoods if you want to do your own custom work. Or maybe you want something a little bit more exotic like caiman or elephant leather. Well, they have that too. And if you're an iron worker, Outlaw makes bolt bags, scabbards, and sleever bar holders as well. And yes, they're fully customizable. Check out their work at outlawleather.com. You won't be disappointed. And while you're there, check out the other tools and accessories they have to help you out on the job like PPE, hand tools, and filler metals. And if you buy any of their stock leather goods, make sure to use Arc Junkies in the discount box at checkout and save 15% off. Only at outlawleather.com. What is up, Arc Junkies? Welcome to episode 248. I've wanted to talk to somebody about line boring and line welding for quite some time now. Lo and behold, Erik Esslinger from Bore Repair Systems reached out to me about this exact topic and offered to come on the show. Line boring is a section of the industry that doesn't get talked about enough, but has huge potential for anyone looking to get into it. This is actually a process I almost got into when I got out of the military. You'll hear more about that in a minute. Let's go ahead and kick this thing off. Fire up your machine, drop your hood, and turn me up 5.
You're listening to the Arc Junkies Podcast, helping you make every weld better than your last with each episode. And now your host, Jason Becker.
All right, Erik, what's going on?
Oh, nothing much. Just another day in paradise here in Bore Repair Land.
Oh, nice. So I've been trying to find somebody to talk about line boring on the show for a while, because it's something that's always fascinated me in the welding industry that not many people really know about. And I actually discovered line boring because my dad, he used to run heavy equipment and heavy equipment mechanic and all that stuff. And when I got out of the Marine Corps, I almost got into line boring because we were going to, I guess at the time, there wasn't a lot of people that were doing it in the state of Florida, and reached out to this company. And I think that the whole setup was like $10,000. And I was going to meet a guy up in Jacksonville who had an 18-wheeler, and he was going to train me how to do it. But I never pulled the trigger on it. I think I was like 23 or 24 at the time, and I just didn't have my wits about me. It's something I should have got into because apparently it's pretty big here in the state of Florida.
Right. Yeah, absolutely. We found we actually keep, it's so busy down in Florida that we keep a demo truck in Florida where we actually, it's stationed in Orlando at my townhouse. And I've done a ton of training out of that location, as well as driving all over the state and up into Georgia. Last 2 weeks ago was up around North Carolina and did some demos in that neck of the woods, and then down into Georgia. And yeah, it's really, the South is really tons of it going on.
Yeah. So for folks that don't know exactly what line boring is, like I said, it's not really well known through, most students that go through welding school or people that are in the industry, they have no idea what line boring is, that it even exists. So can you walk us
Yeah,
through the process of,
sure.
what is it? Why do we need it?
Right, right. So, in the heavy equipment and construction and mining, I should say, there's all kinds of heavy equipment that has pivot points, and these pivot points, such as where the bucket would attach to the boom on an excavator, that pivots constantly. It's digging in the dirt, and it's constantly seeing wear and tear. And so line boring is needed, and bore welding, to put these worn pivot points. They wear out like crazy, and when they get worn, anybody that's operated one of these machines, they know what a worn out bore on a stick looks like on an excavator, for instance. So it's something that needs to be addressed. And back in the day, before the line boring and bore welding was able to be brought out in the field, you'd have to strip the machine down right down to the parts that needed to be fixed. You'd have to ship them to a machine shop typically, and it would be a tremendous amount of downtime and expense in shipping the equipment. So line boring is the machining out of the bore, and the welding is what's putting the material back in. So when we have a worn out bore, we need to go in with a MIG process and automatically build up the bore to a little bit undersized, and then the line bore is the second stage, where we're going to go in and machine that bore out back to the size to accept either a new pin or new bushing.
It's a pretty cool process, and you guys have an Instagram page. Go ahead and throw that out real quick so people can kind of check that out as we're talking.
Yep. So it's 4 words. It's with an underscore between each one. So it's bore _ welding _ line _ boring.
Okay. It's a pretty cool process because you guys machine out the insides. Well, sometimes you'll machine it back out and then run the welds. Is that correct? Just to kind of get back into a manageable working area?
Yeah, exactly. So so the first thing you'll do is, when you take the machine apart, you take the pins out. The bushings would have to come out as well, and sometimes the bushings would have to be cut out with a torch. Want to get that out of there first. Then you got to see what we've got for a parent boss, or the bore that's in the bucket itself, or the whatever part it is. So we want to measure and see how far out around it is, or how worn out it is, to accept how much we need to build up. So what I tell people when I go out and train them, I tell them, so the first thing you want to do is you want to know that the welding is bore welding, one pass through is going to close that bore down by about 1/4 of an inch. Okay, so we're going to lay a bead through there. It's going to be 1/8 inch thick beads, but you can't count on all 250 thousandths of that. So you've got to machine out about 50, 60 thousandths. So I tell them, if you measure that bore and it's within 150, 160 thousandths of where you need to be, one weld pass will take care of it. So we're going to start off by pre-cutting the bore, getting it cleaned out, getting any of the impurities out. If the bushing or pin, ground up in the base metal there, we don't want to weld over that. We don't want to make hard spots. So we want to machine out just a little bit, few 10, 15 thousandths typically, and then we'll throw our bore welder up in there,
back down to clean metal. Yeah. It's a pretty cool process, because it's almost like, so I guess the bore machine you guys put on there is almost like an internal lathe. So it'll rotate on the inside, clean everything up, and take it back down to a good area, and then you can hook the welding attachment up. Now, do they all ride on the same equipment, or do you have to swap out the whole apparatus, like one setup just for the milling and the boring part, and then you got to take that whole attachment off and put up like a whole new setup to do the welding?
So good question. So you have to use a different drive unit, but the support brackets are actually used by both the welder and the line bore. So in many cases, the way our machine is designed, when you're doing a bucket, for instance, where you've got several bores to do, you can leave the line bore machine mounted into the support bracket, then mount your bore welder on the far side on the other support bracket. So you can weld from one side, machine from the other. So that's often the case. So you don't they share the same brackets. They're not the same drive, but it's we've really streamlined how the two interface. It's very, very simple.
That's
It's
pretty
literally
slick.
just you decouple this feed arm and you slide the bar out of the way. You plug the bore, you take the bearing out the far side, plug the bore welder in, plug the other end into your MIG welder, and you're ready to go.
Okay. Now, how often, or not how often, how long does this process typically take? I know it's gonna vary based on like the diameter and like how worn out it is, but I mean, just for
Right.
like initial setup onto a part, like what time frame are you looking at?
Yeah. So doing a excavator boom, like a small boom with say 2.5 inch bores, you can plan on machining and then welding and then machining to finish in those two bores on the end of the stick in about 4 or 5 hours typically.
Okay. And then when somebody hires like a company or an individual to come out there and get this service performed, are they paying by the inch or paying by the hour or paying by the job, or how's that work?
Yeah, that's a great question too. I get that almost daily. People getting into this ask me, what should I charge for this? And the rates vary quite a bit around the country. And for instance, around the cities, New York City, for instance, is very expensive down there. Everything's expensive.
Everything expensive over in New York.
In the South, it's a little less. So I can tell you what most people do is they will have a setup fee to get the equipment ready to go on the job. So they'll have a setup to get the brackets mounted.
Hmm.
That'll, back in the day when we were doing it, back in when we were designing this equipment and coming up with the perfect design, we used to do it quite a bit. And we would charge $350 to set up on the job, which took about half hour typically. And then for bores, say 2 inch to 3 inch, we would be $350 additional per bore to weld it and machine it. Now I've told people, and that was years ago, so that's probably about half or a quarter of what it should be today. So other people though have a formula where they will figure out the diameter and the depth of the bore, and they'll come up with a charge based on that. We found that to be a little complicated, so when, for instance, we would go 350 per bore to weld and machine up to say 3 inch, and then 3 to 4 we'd add another 100, 4 to 5 another 100 over that. So
Okay. And then how difficult is it to learn how to set all this stuff up and do it? I mean, I understand it's virtually an automated system, but you still have to be a good operator to understand, I need to tweak this and change that. So I mean, like
yeah.
what's the learning curve on all that?
So what I like to do is I work with people that buy this equipment that are welders, and I work with people who are machinists. Sometimes they have experience with both. A lot of times they don't. So when I get a guy in here that's buying one of our systems, the training, I usually, the training time is generally a day. It's about 4 to 6 hours. We'll break for lunch. But what I like to do is I custom tailor the training based on what their experience level is. So if they're real good welders, I'll spend most of their time with the machining, and vice versa. If they're machinists and they're not real comfortable with the welding, I'll spend more time with the welding.
It's a pretty interesting process, and then it's not just limited to buckets and attachments. I mean, you can do pretty much anything that articulates
Yeah,
on a piece of heavy equipment.
right, right. I've been involved with years ago. There was a yacht that was down in Connecticut, and it had sat a little too long, and the rudder shaft seized up with the bushing in the boat itself, and it spun the bushing, and that was a no-go. They couldn't have that, so they called me in to come down with our equipment, and we did kind of emergency repair on that. So that's another example. I mean, the shipyards, there's all sorts of pivots on ships even. So
Yeah, I never even thought about that application of it.
yeah,
That's pretty. And then I would imagine you could do that on cranes as well. Do you guys ever service
yeah.
cranes?
We don't, but we have a number of clients that do. We have one that comes to mind in the UK that has, I think, three complete systems, and that's all they do. And they're nonstop, just welding, machining, and repairing these booms on cranes. Yeah.
Damn. And then I know it's also, I don't know if you're familiar, there's a company in Central Florida called Pemberton, and they build,
Attachments. Yep.
yeah, they build attachments for, I mean, like you name it, even
Right.
custom stuff. but they'll weld everything up and they try to get all their pivot points as inline as possible. But I guess
Right.
they hire a company to come in and do the line boring after it's been manufactured to make sure
Right.
all the holes and stuff are true. That way, when the piece of equipment attaches to it and drops the pins, everything lines up just perfect.
Yep. Yep.
Yeah,
Yeah,
it's pretty cool
that's
stuff.
absolutely true. Yeah, I've worked with a number of companies who are new manufacturers of attachments, buckets, and things, and that's exactly, they used to do it on stationary mills, and they would not be real. They wouldn't be feeling the amount of time it takes to get things lined up in the stationary mill, and they love the fact that the line board machine sets up so fast, and it's being portable. You can be set up and running typically on a new weldment like that in just a matter of minutes.
Damn, that's pretty slick. And then do you guys make it in different sizes, or is it like a one size fits all solution to where you just add different attachments and you can kind of do bigger bores?
Yeah, so the first thing we'll do if you call up and you say, "Hey, Eric, I'm interested in looking at what you have for line bore equipment and welding," I'll first ask them, what sort of jobs are you going to be doing with it? And 90% of the time, it's we're going to be repairing bucket bores and bores on booms on excavators and things like that. And that the size range of the bores in that area is generally between 2 to 6 inch in diameter, and so that size range would fit into our BRS2C package, and which out of the box that will do a bore from 1.9 up to 10 inch. And that covers a lot of people's requirements. Now that machine can be added onto. So back to your question about attachments. Yeah, there's actually attachments to get that machine. So it will now be able to weld and machine down as small as 1 inch. So then you can then go into the arena of repairing skid steers, things like that, or those little micro excavators, and very small equipment with very tiny bores. We also can go on the bigger side if you needed to go over 10 now and then. There's an attachment that can be added to take you up to 14. So, and
Sheesh.
then we've got things like automatic face cutters and automatic face welders and things like that as well, that are further attachments and further accessorizes your equipment.
Hmm. Now, can you run? I'm not sure how familiar you are with like different welding processes, but can you run different modes of metal transfer on that, or is it like limited? Do you know if the MIG welder is like limited to short circuit, or can you get into like a pulse spray or something like that? I mean, because it's not structural; it's more like surfacing or material buildup. Is
Yeah.
that a big
Yeah.
factor? Is getting good penetration on there?
Yeah. So I have been most of what we do is short arc MIG, but absolutely, spray is done in certain applications, but 99% of the time when you're doing spray, you've got to get into the vertical position. You can see behind me,
Hmm.
that's a typical heavy equipment job right there, where you're going to be all horizontal, and the welds are going to creep on you at 9 o'clock and 3 o'clock coming up, and overhead as well. So that's going to be all MIG and short arc. But for jobs where you can put them vertical, you can run those higher voltages, and the higher heats are okay if in that vertical position. You won't have that creep.
So your equipment would be in the vertical position, but the welds would be actually done horizontal.
Right, right,
Okay, yeah, and then
yeah,
I would imagine you'd start off at the bottom of the bore and then
right.
kind of work your way up, kind of building,
Yep,
almost like a spiral staircase up the whole way.
right. Yep.
Damn. So how did you get into this industry or this line of work? Because you said you guys developed a lot of this stuff.
Yeah, we did. So many years ago, back in the late '80s, actually, I was involved in the startup of a company that came up with a drill press that had a welding head on it. Now, I was in college at the time. I was studying industrial technology. That was my degree, which is kind of a combination of design and business management, a little bit of CNC work, things of that nature. It gave you kind of a taste of everything. It wasn't any one focus on one thing. It was a broad assortment of things. And that actually fits pretty good for what I do today. So anyway, when I was in college, I was working my way through school, didn't want to get into too much debt, and I got involved with a startup company who came up with a welding, basically, like I said, it was like a drill press that welded. it could be turned to go real slow. And it was to weld up like worn out bores you'd find on hydraulic cylinder ends and things like that, cylinder eyes. So long story, so just to jump forward, so I worked my way through college, assembling these machines. And then a year or two after I got through college, I got into more of the marketing, doing trade shows, doing the AWS shows all over the place. And that machine was very interesting. It was kind of the first of its kind in the States. But the problem it had was it was very complicated. It was very expensive to make, and it had durability was always an issue with it in these environments. When you take these machines into mines and your job sites and whatnot, it's got to be a clean, bulletproof design, or it's not going to last. And it just wasn't. So about 5-6 years into that, that company actually got bought up by another outfit. And at that time, and I wasn't going with them. And at that point, I was thinking of going back to college, but I had learned so much in this industry. It was kind of cool. And I've always, I grew up around a farm, and always enjoyed taking equipment apart, putting it back together, fixing it. So I kind of liked it. And I said, you know what? I should kind of stick with this. And my dad he's got a design degree as well. And we ended up being approached by a company overseas that said, this other machine, we like these automated bore welding machines, but can you guys come up with a simpler way to do it that's more durable? And we, in 95, 96, we actually came up with, just kind of started thinking, like, is there a simpler way to do it? And you think about how a nut and a bolt works together. Well, the motion we need for bore welding is rotation and feeding, axial feeding. So we came up with kind of the way a nut and a bolt works. If we can get a welding head attached to the bolt per se, and then we can make a swivel. The biggest problem was getting a swivel power connector that wouldn't overheat and
work
so
while you're welding, so you're not arcing things out the whole time.
So we're rotating, so that's a bit of a challenge. So, but anyways, we have this little shop here, which before we did the line boring and welding, we actually had what's called noise reduction products, which is a sheet metal shop, which makes panels to quiet down noisy machines in all sorts of shops, GE and whatnot. So anyway, we had this equipment. We had a little lathe in the corner, and we were able to fabricate some just rough, basically come up with some rough machining and put some products together and kind of test our ideas. And before about 3 or 4 months, if I remember right, we had a working bore welder that was like 1/3 the parts of this welding drill press thing. So I think we got something here. So we kind of refined it over the next 6-9 months, got 4 or 5 built, and we sent them to the guy over in Africa that was asking about them. He said, we have a need for this simple bore welder. We said, well, have at it. And he actually loved them, and he sold them all like in record time. And we say, hey, we got a winner here. So let's start a company and go from there. So that's how it all started, just kind of by accident in a way.
Now, how many companies are manufacturing bore welding equipment?
Let's see. 1, 2. I only know of about 4 others. Okay. Maybe 5. I think there might be 5 now. Yeah.
Damn. Yeah. It's a really, like I said, it's a really cool process. Something I've always been fascinated with. Now, how much, like with the operator and everything, how much are they like on there watching? I mean, is it more along the lines of the old school Ronco rotisserie chicken? Do you just set it and forget it and just kind of monitor it? Or does the operator actually have to sit there and play around with like feed speeds and voltage and wire feed speed and like, the rotational speeds and, the axial speeds and all that stuff? I mean, do you have to fine tune that as you're going the whole time, or is it pretty much just line it up and hit the go button?
Yeah, it's pretty neat, because back to the original machine that was too complicated, it had all these settings to adjust the feed rate. So you had to get your feed rate just right, or you weren't going to have base fusion. The beads would just build up on each other and they wouldn't be fused into the base metal. So our machine, that was one thing we knew. We didn't want to have a motor to run the stepping part. So we'll use the old, we found out through trial and error that the perfect amount every time you rotate, perfect amount for that bead to axial feed would be 1/8 of an inch. So we put our feed screw is threaded on the outside. It's got an Acme thread with an 1/8 inch pitch. So you don't have to worry anymore about setting your feed rate right. The rotation speed, it's happiest running at about 20 surface inches a minute. So we actually print a little chart on the front of the bore welder where you measure your bore and you look on this chart and it's going to tell you where to set your rotation speed dial. So that's all set. The last thing you need to worry about is your voltage and your wire feed speed or your amperage. And the most machines are happiest right around 17 volts and about 215 inches or so a minute. We're running 030 wire typically through these bores. And so the amperage is typically around 105, 110 when you're running the bore welder. And once you've figured out what your particular MIG wire feed welder likes to run at with the bore welder, you pretty much don't have to ever mess with it again. I've got guys that just put a mark on the dial. Their wire feed is here and the voltage is 17.5 or whatever. And so that's all done.
It's pretty common in the industry.
It's really simple. And so once it's running and laying a nice bead, usually you're going to stay there for that first bead and just listen, how it should sound. It's nice and crispy, and make sure your bead is laying in there nice. Once that first one and then the second comes around good, you might tweak it a little bit from the first to the second, but then it's pretty much going to do its own things. You can walk away and if you have enough brackets, we sell a lot of people these machines they'll buy a second set of brackets so they can actually be setting up on the second job while the bore welder's doing its thing. So it's pretty neat.
Stay productive with it.
Yeah. Yep.
That would make sense. I mean, while it's, welding out the other one, you can go ahead and prep up and get everything set for the next one. So that makes sense. Now, do you have to do like any preheating or anything like that? Because I mean, some of these sections that you're working on is pretty thick stuff.
Right. Definitely preheating is nice to do if you want to get a nice wet in on that initial couple of revolutions, which if a lot of people don't do it, but I certainly recommend it. But most people are like, I don't want to mess around having to preheat anything. They just want to get it done quick. But and if they don't preheat, what I always tell them is if that chart on the bore welder says set your dial at 2.5, let's go a little slow for the first couple of revolutions, get the chill out of the part.
Get that heat input in there.
That's going to help them wet in better in the rest of the way out, and that's what they do. And but yeah, a little preheat, 150, 180 Fahrenheit really helps that wet in nice when it first starts that initial couple beads.
Okay, and then like as far as the welding machine goes, I would imagine that's customer provided, but does it run off of like a suitcase welder, like a Lincoln LN25 or like a Miller suitcase or something like that?
Yeah, probably the most common feeders would be the LN25, the LN25 Pro. People couple them up with, if their service truck is equipped with a Ranger, for instance, they'll run a Ranger or anything like as good as that or better. On the Millers, the 12 RCs, 12 ESs, those suitcases are very popular, along with the Trailblazers or fancier than that.
And then your equipment's is it plug and play directly into that? So like whatever they buy is going to dictate, or, like the piece of equipment that they already own is going to dictate, attachments and, stuff that they need from y'all.
Right. So we've standardized the ends on our bore welder whips. We call the whip part that plugs into the feeder. We standardized to a Euro connection, which is very popular pretty much everywhere but here.
Yeah.
You go, you ship it over it's like the metric system. They've all figured out, but we're being stubborn. So anyways, that's fine. So we've got adapters for the Millers and the Lincolns and all that. So when somebody buys a system, if they're here in the States, we ask them, what are you going to run the bore welder with? And then we provide the system along with this adapter. So it'll be plug and play. They'll have to unplug their handgun and just plug this adapter in. It's all pre-wired, so it's no fuss really. Just plug it in, tighten the tighten the clamp and then plug your 4-pin amp connector, your 5, whatever unit you're running. It's
Okay.
really easy.
Yeah. Now, how in demand is like this process like throughout the U.S.? I mean, I would imagine it's you probably got people on waiting lists to for to get service performed because there's not I mean, you only have 5 companies manufacturing this type of equipment.
Yeah.
How many people are actually out in the field, doing it? Is it pretty in demand? There's still room for other people to get into this industry and make a killing?
It's crazy, you'd think after all these years, I mean, we're talking, we started back in the mid 90s, and you'd think there'd be market saturation at some point, especially this many years later. And you know what? There is still countless times when I get a phone call and there's nobody in my area doing this, and there's a huge opportunity for me. I've had so many people tell me that, and it just blows you away. Even in cities, in areas that I know we've sold half a dozen or even a dozen systems there, still there's more work than people doing it. It's really something. So it's really an exciting industry for me. I love it. I love getting out there and just seeing the excitement that they have. They're like, so many people I've had people call up and say, I've got enough jobs lined up. So I'm going to have this thing paid off in less than a month, because I've got that much work already lined up before they even have the machine.
Damn. Now, like, obviously, you don't want to give, you want to call for a quote and everything, but like ballpark, what's like your system cost from the one that you said starts off at like 1.9 inches up to 10 inches, I believe.
Yep. That's the BRS 2C package, and 24,895 is the exact price if you get the 120 volt version of it. It's about $300 more if you go with the 240 version.
Yeah, definitely take that upgrade.
Yep.
That's not too
So yeah.
bad. I mean, you can build an entire business off of that for 24
Oh, I
grand.
know. Yeah, it's really something because if you look at what some of the big heavy equipment dealers charge for this, you could pray if you had this thing working 3 days a week, you could probably pay it off in less than 2 months. Probably way less, probably 1 month, no problem.
Yeah,
But
with the amount of work that's out there, you're probably gonna be working
yeah,
closer to 6, 7 days a week.
yeah, yeah, that happens a lot. People get these units, they have a couple jobs lined up, and before long, they've got people calling them left and right. Once they hear, hey, this guy's got the equipment to do it, and he's doing it right. He learned how to do it, run it right. And man, it's really something to see how much. And they never spend any money on marketing. That's the crazy thing. We have to spend money on marketing, but not them.
No, it's all word of mouth. It's like, oh yeah, we
Yeah,
got a guy that does that. But I mean, that's the thing is people don't realize it, and I didn't realize it until my dad explained it. And he goes, when you have a piece of heavy equipment down on a job site, it's costing you money, not just
yeah,
because you're paying a lease on it, but I mean, you've anticipated that machine to move X amount of yards per day, and
yeah,
now it's not moving anything. It's sitting there. So
yeah.
now it's eating into your bottom line. So like the companies, they want to get somebody out there and get that service like now.
Absolutely. Yeah, yeah, it's true.
Yeah, because I mean, you look at the investment of a piece of heavy equipment or like that bucket that's sitting behind you. I don't know how big that bucket is. I mean, it looks pretty substantial, but you look at that and then you want to protect that investment. So
Exactly.
as soon as it starts to wear out and everything, you want to get somebody in there to maintain that, fix it, get it back true to size and everything. Otherwise, it's tearing up other parts and components on
That's
the heavy
right.
equipment.
Yep, for sure. No, it's been really quite a journey. I'm very grateful I got involved with this back when I did, because it's kind of like I said, it kind of fell into it just by accident. So
Yeah. And the wire you're using, is it just like regular 70S6 wires or some kind of specific well, I guess it's gonna depend on, what type of material or whatever they're welding on. But is that pretty
yeah,
70S6 pretty common?
yeah, 70 S6 is the most common one we use. Sometimes some people use the S3, but the S6 is by far the most common. Good copper coated solid wire. We like the Lincoln L56 wire, for instance. That works great.
It's a good choice.
Uh,
Now, are there applications for like other types of alloys? Do you guys ever do anything on like aluminum or stainless or anything like that? Because I would
yeah,
imagine at the end of the
yeah,
day, a hole's a hole.
yeah. Hole's a hole, right? Stainless steel for sure. I was involved a few years ago. We sold a machine to a company that was a food processing plant, and they had I'm not sure what they made there, but they had a number of these holes that were getting worn out from the products they were forcing through these pipes. These valves just eroded the bores, and they'd have to build them up now and then. And so that was all stainless. That when that machine went in, it was never going to see anything but stainless steel. Aluminum, I got that question the other day, and I don't know of anybody doing that, but if you can get the wire that's in the 30 or 35 thousandths, you can run it through that bore welder. If aluminum bronze is one that comes to mind. We did not too long ago. There was a casting that was a bit of a challenge to weld, and that required quite a preheat. I think it was about 400-degree preheat and we had to spray it in there. But so yeah, any wires, if you can fit the wire through the bore welder, it'll happily rotate and feed for you.
So
as long as you get the right power supply on the other end.
Can you run, I would imagine you could also run like a flux cord wire as well if need be.
Yeah. I was at a mine where there was a lot of wind going on, and that's a good question because they wanted to run flux core, and we did run the flux core. The problem we had, this is a great big bore. It was about 18 inches or so. We were able to run about 3 revolutions before we had to stop and clean the nozzle out. So it was a constant hassle with cleaning the nozzle out. And the other problem with the flux wire I found is when you run a robotic system like this, especially a circular bore welder, where you're running bores inside welds inside of a bore and you're rotating the head, you come to a point where that wire wants to flip on you. So the straighter the wire, the better. And if that wire is not real straight, you get that flip point. And generally it's just cosmetic until you machine it out. But you can get a severe flip where the bead is tracking real nice, and then it's tying into the prior bead, and all of a sudden you get this zigzag shape. And it'll actually be enough in some cases if the wire has a real tight cast to it, where it'll flip to the point where you've got a void that goes right back to the base metal. And does that really matter in a piece of heavy equipment? You wouldn't want that a lot of places, but in 1 or 2 little spots isn't going to be the end of the world if it's a bushing being pressed in there. But straighter the wire, the better. So that's one of the big problems with flux wire is that it comes off the spool with a lot of curve to it.
That would make sense. And I heard that for folks that don't understand, like the cast of the wire is almost like the memory of the wire. So when they roll it onto the spool, that material develops a memory. So it knows it's used to being in that 10 or 12 inch, circle, I guess. And when it comes out, it kind of wants to maintain that shape. I didn't realize that was a big issue until I went to an AWS meeting and they had Sandvik come in, and they're like really big and different stainless wires and everything. And they had to calculate the helical twist because stainless apparently has a very good memory. So they had to figure out a way to do that to where it wouldn't, come out of the nozzle in a helical twist.
Right.
Damn. Yep. Yeah, that's pretty neat. There's a lot of science into this stuff.
There is. Yeah. And then the other question I get all the time is, well, what gas should I use? And it's in general, most people run 75-25 argon CO2. I like to have people start off with that because you probably know more about it than I do, but when you run with 75-25, the weld bead is a little less fluid than if you run a higher argon gas like 92.8, right?
Yeah, you can. Yeah, you're getting into more of a spray transfer once you get above about 80. Nate and I, my buddy Nate Bowman, we go back and forth all the time. I always say, he says 80, I say 82. I like to stay safe and just run 85-15 if I run spray transfer. That way, if whoever's mixing the sauce there, if he's off a percent or two, it's not gonna, I'll still be able to do what I need to do with it.
Yeah. So. And then if you're running a real nice inverter, and it's a real precise machine, I found that running 92.8 can give you a really nice bead, but you have to be careful not going too hot on your voltage. But what I like about that higher argon is you get a little less spatter, so you can run a lot longer without having to clean your cup out.
All right, we're going to go ahead and take a quick commercial break. This segment of the Arc Junkies podcast is brought to you by O2 Armor, slayers of the black boogers. Think about all the crap you're breathing in around your shop. Grinding dust, weld fumes, and a whole host of other debris. Block out all that crap with O2 Armor. They filtered particulate down to 2.5 micron. You can get your O2 Armor filters today at O2Armor.com and save 10% when you use Arc Junkies 10 at checkout. You can either breathe it in or block it with O2 Armor. We're also brought to you by Strong Hand Tools, makers of my favorite fabrication and tooling. Educators, do you want to get your hands on some Strong Hand tools? The answer to that question is yes. Yes, you do. Do yourself a favor and go to stronghandtools.com/ArcJunkies and sign up for their discount program and get a free set of tools for your school. That's stronghandtools.com/ArcJunkies. We're also brought to you by Everlast Welders. They make machines and plasma cutters for every budget and skill level. Everlast is the perfect choice for your home shop or small business. And all IGBT inverters come with a 5-year warranty. Head on over to everlastwelders.com today and see which machine is right for you. I personally run the 255 EXT for all my AC and DC TIG operations and the Cyclone 200E for all my solid wire MIG. It's a great combo. And if you buy any machine that comes with a stock foot pedal, be sure to get that free Nova foot pedal and TIG Torch upgrade by using Arc Junkies in the comment section at checkout, or just click in the show notes. Everlast Welders. Weld mean, weld green. Now let's get back to the show. That and a good ceramic like nozzle dip. What's the name of that company? Contesco. They make a ceramic nozzle dip. It's not a nozzle. It's a spray on, and like you can run an 8-hour shift with that stuff. I mean, it's amazing. But yeah, you got to get the nozzle. If I remember correctly, you want to get the nozzle hot first. So you just like weld on a piece of scrap, and then you spray that nozzle spray in there, and it puts a ceramic coating on there. You let it dry. And I mean, that stuff's the freaking bee's knees.
Have to try some.
Yeah. Now, when I guess the companies or whatever that are buying this equipment, when they go out to the job site, I would assume that everything's detached and nice and clean and, ready for them to work on. So they're not pulling the buckets off or, taking the arms off the attachments, or am I completely off base here?
Yeah, that's definitely what you want the client to do, is pull it all apart and degrease everything. Does that happen? If you don't, I think back to a time when I went out, I get hired all the time to go out and train people how to run this stuff. And I got brought out to a job one time where there was no cleaning of the part whatsoever. They didn't split it or anything. And we must have spent half the day just doing that. So yeah, absolutely. You want to have that all taken care of, because you should be coming in as the bore repair specialist, not the pull apart the equipment and degrease guy with, that's not what you want to be spending your time with. So
you can get away with that by you charge like $300 an hour for cleaning and all that stuff, and they'll get it done for you.
Exactly.
Next time you show up, man, it'll be there up on stilts and everything.
Yeah. Yep. For sure.
Yeah. So now, do you see like a lot of companies buying this to maintain their own fleet and just having like an in-house guy to do this, or is it just there's not enough work, they'd rather just subcontract it out?
It's all across the board. We sell from, one-man shows that might have a weld shop. They might have had a welding business, just general welding business for the last 5-10 years. And they want to diversify a little bit, and they see a demand for it. And we'll sell to guys like that probably just as often as we sell to big companies who want to maintain their fleet. So it's kind of all over the map. I would say it's a split.
Pretty good mix.
The one man. Yep.
Okay. And then like all of the I guess consumables. So you've got like cutters and everything. Are they pretty much like stock items, or are they like specialty to your components? So like contact tips and the cutters and all that stuff.
Right. So in the contact tips with a welder, we use there's a variety of different consumables. So when you're doing small bores, we have what's called a mini diffuser, a mini nozzle, and a stub tip, we call it. And the mini setup is proprietary to we couldn't find anything that was on the market that we could use for that application. So we designed our own. So when you're doing the bores from 1.25 inch up to about 2 inch roughly, you're going to use these mini components that you have to get from us. When you get from 2 inch to 4, you're going to use that same, what we call the stub tip, but you're going to use a slightly modified Tweco nozzle or gas diffuser, or I guess nozzle's the right term, right? Not gas shield.
The nozzle just shields the gas, and then the diffuser holds the contact tip primarily.
Right. So we use very similar to a Tweco setup, and you could actually take a Tweco nozzle and shorten it. One of those tapered Tweco nozzles, you just shorten it, and you got the same thing as our what we call the stub nozzle or gas shield. And then the diffuser is the same as an off-the-shelf Tweco, with the exception of it's a little bit shorter where it threads into the gun body because it's such a compact little gun body.
Mm-hmm.
We went full length with a full Tweco, it's going to bottom out and kink the liner. So, but when you're doing the bigger bores, use an off-the-shelf Tweco. I think it's 1130, 1135 Tweco tip. And the other thing that we do, and that can use a regular Tweco nozzle. One other thing we do, though, and we always tell people, you don't have to use our consumables, but we do these little things like on the gas shield, we make it so the insulator piece is what touches against the gun body, which keeps that electrically isolated, so that if you're welding up inside a bore and maybe you're going too fast that day and you didn't get quite centered up like you should, and it's dragging a little bit, it's not going to arc out on you. If you use a regular Tweco nozzle that's not modified, the copper is going to be what's buttoned up against that live gun body, and then when it makes contact, it's going to arc out. So there's little things like that that we do that make it that much better for this type of application. But a lot of people do run their own consumables because you can get them. I mean, we want it that way, so that if you're working on a weekend and you burned up your last tip, you can use a Tweco. You can go down to Home Depot and probably find them.
Yeah. And then what about like the cutting blades? Are they proprietary to you guys, or like just off the shelf through MSC?
So the real common ones are we use high speed steel cobalt mix for our general purpose bits, and those there's nothing fancy about that other than the way we grind them. So the geometry of the cutting bit is very important for line boring to work right. So you can't just go over to your lathe and grab bits that you used over there and throw it in your line bore and expect it to work right. You're going to get tool chatter most likely, or broken bits left and right. So we have a special grind that we do, but we provide, I believe in our manual, we actually provide the geometry. So if you wanted to buy some blanks and go to a machine shop that does tool grinding, you could have 50 of them made up if you want to do it that way.
Okay.
But our high-speed steel bits are nothing fancy other than the way they're sharpened. And then we do have what's called ultra carbide, which is our own design indexable carbides, and those work absolutely awesome. And we came up with them about 4 years ago now, and now those were an option. Now they're included in every system. So, and now for ID cutting and all that, you can't beat it, because you basically are doubling your speed with these carbides. The high speed steel is great and it's tough, but you have to go slower than you do with the carbide. Carbides can take a lot of speed, and you're not going to lose the edge.
Now, like, what kind of RPMs are you running with the cutting attachments?
Yeah, so with the high speed, we provide a chart in the owner's manual that tells you if you're cutting a bore that's between, say, 1 and 2 inch, you use this speed, which is 4th gear, and then you've got a rheostat to fine tune your speed. The bar speed for a small bore like that, if you're using the carbide, would be probably around 230 to 250 RPM or so. But if you're using the high speed steel, you've got to throttle that way back. And when you're using the high speed steel, you kind of have to look at the chips that are coming off, and you don't want to have discolored chips. You don't want to have blue chips or gold ones when you're using the high speed steel typically, or you're going to dull that up.
Yeah, because
with the carbides, doesn't matter.
At that point.
But,
yeah.
So it varies, depending on the size of the bore. But the machine has a capability of rotating the bar. It's got a 4-speed transmission on it, on the motor, and it's got a rheostat to give you fine speed control, each of those 4. So full throttle in 1st gear would be probably about, I think it's around 70 RPM. If you put it in 4th, max the throttle out, you're going to be just under 300 RPM. So it's good for carbide or high speed steel. That machine can handle whatever you throw at it cutter wise.
Okay. And then the attachment head for like the welding portion,
yeah,
I would imagine that's not at a 90-degree angle. So what right. kind of angle are you kicking that off at? Because at a 90, your wire's just going to bind up. I mean, you can't push wire at a 90-degree angle really efficiently.
Right. So the angle of attack on the end of the gun is going to be about a 45. And and you can adjust. You've got fine adjustments, so you can adjust that angle slightly depending on the size of the bore that you're working in. If you go straight in with like a mini setup, you're going to be able to go and do an 1.25 inch bore with it straight. If you bend it in a little, if you pivot that a little bit, it's going to then be able to do, pivot it all the way. It'll go up to a 2-inch bore. And then once you get to 2, you're going to swap out those mini components with the mid-size. We call them the stub components. Then that's going to go back to straight, and then it's going to bend in so 2 to 4 inch is going to be from here to here. So it'll vary slightly, but not a lot.
Okay.
45 is the main, is the that's what the end of the gun when it's straight is attacking the face of the bore at.
Yeah, I would imagine everything would have to change just depending on the geometry of the hole and
Right.
everything. So how do you you ever get like an oblong hole where you
Yeah.
it's not perfectly symmetrical? So how do you get in
Yep.
there with those different contact tip to work distances? I mean, especially if it's like ate up pretty bad. I mean, if you try to
Right.
center everything up and true it up to an oval,
Yeah.
you're gonna have, half of it's gonna be all wonky.
Yeah. So setting up, that's one of the things I always go over with the guys that come in here for the training class. And oftentimes you do end up with a hole that's got a worn out area in the bottom or a certain area. And your first thing you're going to do is use centering cones to get everything set up. So you got centering cones and the bar that's going to be ultimately turning your bit. And that's what you're going to use as your setup. So when you've got a oblong hole, you've got that cone is wanting to drop down into that worn out area. So I've come up with these I tell people you can make these little flat piece of steel, bend it into an L, and various thicknesses. You can drop that into that worn spot, and then that's going to trick the cone. The cone is going to then, the rest of the bore a lot of times is round, and then that little piece of material is going to kick that cone back up, so it's going to be a lot closer to centered, if that makes sense. Oftentimes you can get fairly close with your centering with the cones and that method using some flat stock bent into an L, or trick the cone. If you're doing bigger bores, you actually have these cones that have these extensions, and a lot of times you can set the extensions. If you're doing a bore that's over 4 inch, the extensions can be, there's 3 of them around the perimeter of the cone, so you can rotate your cone so that the extension legs are skipping over the worn spots and getting you much closer to center that way. But that's not always there might be wear all over the place, and that can require some after the fact fine tuning after the cones are taken away. So that's in the fine tuning, you're going to use squares. You're going to use a machinist square and maybe one of those angle finders, and find another part of the bucket or the part you're working on that that you can use as a something to measure off of to kind of
Get back into center.
Back to center. And then once you're set up in that situation, in that worn out bore, and you need to weld it, let's say you got 3/4 of the weld is 3/4 of the bore is round, and then you've got this low spot. I had a guy years ago that told me, what he does is actually puts the bore welder into neutral, and then he'll push the gun through the low spot and lay the beads the long way through the bore in that worn spot, and then he'll kick the gun out and then do a 360 pass over that.
Oh, okay.
And
So
it
you
works
just
out really good.
kind of do like a surface buildup before you do a surface buildup.
Yeah, surface buildup of that worn trough area, and then you do a 360 over that. Now you can, if you want to get fancy, you can use the auto skip or the skipping feature, where you've got a manual skip that will allow you to weld in that low spot. You can click a switch and it's going to rotate independently of the arc, so you can tell it, okay, I just want you to weld this lower quadrant or wherever. There's also a version of the bore welder that you can set these cams up you can set the cam so it will automatically skip for you. So there's many ways of dealing with these worn out bores.
Kind of like a limit switch in there. It will kick it on,
Yeah,
kick it
yeah.
off.
Yeah, and you can tell it to weld 1 degree up to 180, or skip 1 to 180, or anywhere in between. So, or weld 364 and skip one little degree. So anywhere from around that bore. You can program it to do what you want.
It's pretty slick.
Yeah.
So is when somebody goes to, like, they buy this equipment, they get all set up. Obviously, you're gonna need a work truck with boxes and all that stuff on there to hold all your different components. Do you have to have a helper with you, or can this be like a one person operation? Like, how heavy is this equipment to where, can one person do it alone, or is it like a team of two people typically?
Yeah, usually, like I said, we've got shops who one man show that buys this system and they're dealing with it themselves. The way we package the equipment, it's kind of neat. It now comes in a jobber box where you can take out the components that you need to do your setup first without having to pull the whole box out of the truck. So you just pull the centering cones out, and you slide your bar out and you do your setup, and you don't need a helper for that. And we've also made it so you don't need a helper. Like before we came up with this cone pusher device, you did need a helper to kind of help you squeeze the cones in tight so that you got a good center. But now we have this mechanical means of tightening the cones so that they jam in, so you don't need a helper helping you tighten the bar clamps when you're doing it. So
Okay.
and if you wanted to unload the whole unit out of the truck, it does weigh about 250 pounds when the bore welder and line bore system is in the jobber box in your truck. So you definitely would want to help with that unless you're pretty rugged, but
Be a big
you don't
dude.
need to pull it down a lot of time. You just pull the centering components out of the top and get that all done. Then you pull the tray out, and then you've got your gearbox pulls out. You plug that in, and your bore welder's down there. And then before long, it's an empty box that you can pull down if you needed to.
Kind of like Johnny Cash, one piece at a time.
Yeah,
Okay.
exactly.
Yeah, because I was wondering, like, that, because like I can see it, the viewers can't see it, but or the listeners can't see it, but like I can see the apparatus you got hung on the bucket back there, and I'm like, damn, well, you need like a small gantry crane on the back of the truck, or do you hook up like a little jib on the bucket, or what, to get all that stuff in there?
The beauty is that those components are all, there's nothing over like 20 pounds there, believe it or not.
Oh,
So,
that's
and
not
they
bad
all
at
break
all.
down. That motor with the green stripe on it there, that motor weighs about maybe 15 pounds. The gearbox that it's plugged into, which actually drives the bar, that's maybe 18, 20 pounds maybe. So it breaks down into manageable chunks. And the support brackets are another 10 pounds each or so. Yeah. So,
It's a nice design.
yeah.
Yeah, that's the last thing you want to do is like tear a rotator cuff while you're out there trying to make money.
Yeah, exactly.
Wow.
Sure.
So
Yeah.
what are some of the other applications that this is being used that you never, this wasn't the intended design, but it's actually being used in this type of industry?
Yeah, the line bore, I can't think of any industries that it's being used at currently that I couldn't envision, but the bore welder definitely has some places other than heavy equipment repair. Like machine shops like to have access to a bore welder. Why? Because let's say you're working on a real expensive part, and you machine the part that you're working on. Maybe they mistakenly had the bore that they've just put in this big part that they got $20,000 into. They had it off by 50 thousandths of an inch, and they're like, "Oh my gosh, do we have to scrap this thing?" Or if they can bore weld it up, they can put material back in and then reposition their bore, and then fix it, basically save it. So that would be one thing that comes to mind. The marine industry is one that I never used to think of until that day we got called in to do that rudder shaft repair. And so that's one that actually we haven't sold a lot to the marine industry, but I think there's probably a lot there,
Yeah, you got to start
a
tapping
lot of
into that market,
application.
especially in Florida.
Yeah, exactly. Yep.
Yeah, hit up Jacksonville and Tampa area. Yeah, there'd be a
Hmm.
lot up there.
Yeah. Yep. For sure. Other than that, I can't think of too many off the top of my head right now, but certainly the heavy equipment, the mining, and those are the big ones. Yeah.
Yeah, that'd be a good process, or like a good setup for somebody to get into that wants to do a small business.
Right.
That they don't have a whole lot of money to invest. Because, like you said, that whole system's like 24 grand. But I
Mm.
mean, that's a tax write off right there, and then you just write off your depreciation every year. But I mean,
Yep.
you can make that back in a couple of months. You get that in a work truck and a
Yep.
weld machine. I mean, you're off to the races, and I mean, business would be booming. I think
Right.
that was the thing, all the people that I talked to that, required line boring, they said, "Oh yeah, it's great if you can get somebody out here."
Yep.
There's only like two people that, in this area that we can really rely on to be here when they say they're going to be here.
Right.
So I mean, there's definitely enough work out there for more people.
Right. Right. Yeah, absolutely.
And then you have because I think you've got a place up in the Northeast U.S. and then you've got like a shop here in Central Florida as well, right?
So the main shop where I'm sitting right now is in New Hampshire. That's where these machines are built. That's where the main training center is. We build them here. We train people here. We ship them out of here, assemble them here, all that good stuff. The Florida location is really just kind of a satellite office that I go down to every roughly 4 to 6 weeks, because we do have a lot of interest in the southern marketplace. And years ago, I used to spend a lot of time driving back and forth, and it became clear this doesn't make sense. So we got a place down there, and we keep a demo truck down there with a MIG welder. I can go in and do a demonstration. 15 minutes, I can be set up and doing a demo of this equipment wherever you are, in Florida. So
And then you're doing live welding and machining while you're there.
yeah, exactly.
What are
Yeah,
you
training. Yep.
attaching it to?
We've got a little mock-up of a couple of bores. They're about 3 inches or so in diameter. Just a couple bores spaced about maybe foot apart, maybe 18 inches, and it's just kind of like what you'd see on a typical small excavator bucket.
Okay.
But what I do is I'll go into a shop, I'll plug my actually I don't know if you're familiar with the Feronius little trans steel welders,
Yeah.
but those things are great,
Yeah, they're
and I can
slick.
plug. I used to travel with the three-phase Miller, and I spent a lot of time trying to adapt my machine so I could plug into the power at whatever shop I'm at, and that nobody ever has the same twist lock connection on the wall. So
Yep.
when I switched over to these trans steels that I found about 5 years ago in Australia, I said, "Man, these are great," and they actually are so I can plug in and I can get my 105 amps, 100% duty cycle plugged into 110. So that's all I need for my bore welding. So
Damn.
I'll wheel into the shop, I'll plug it in and do my welding, and then I'll switch over and show them how to then do the machining. So I'll do a full demonstration of the welding and machining, and it only takes about an hour to do the whole thing.
Okay. Yeah, I'm looking forward to having you come down for the
Yeah,
AWS section meeting. I got to get you a date for that, but
yeah, absolutely.
I think that'd be awesome to show that to the
Yeah, I'd
members
love
that
to.
come out to that. And then if you're interested, since you're here in Florida, I've got two other sections that are
Oh yeah,
they'd be interested in seeing that Florida West Coast and then North Central Florida.
that'd be
They
great.
do technical
Love it.
demonstrations and all that, and like especially up in there in North Central Florida, that's one where I did a plant tour up there for Ring Power with Caterpillar.
Yep.
So I mean, that's like where one of their main hubs are. So I would imagine there's a lot of work going on in that area for this type of equipment.
Yeah, yeah,
And
for
then just
sure. Yeah,
expose the students to it, because that's one thing I tell my students, like they're like, what industry should I get into? I was like, find like a niche market, and like
yeah,
I would explain line boring the best I could, show them some videos on YouTube. I was like,
yeah,
this is an industry that I almost got into, but like I came back from Iraq and pissed away all my money, so I didn't. And
yeah,
I wasn't thinking, and it's something
yeah,
I should have got into when I had the chance.
yeah, yeah. No, I'd love to do that, and I agree. It's funny to me that all the trade schools, nobody, as far as I know, has a line boring and bore welding curriculum, and that's something I've thought of for years. I've been at these AWS shows in Chicago and whatnot. I'd be all the time have professors, the guys that teach welding classes, say, "Man, I wish they would bring this equipment into our school and have a little curriculum for it," because I think that's what a great thing to add to your resume, when
Yeah,
you're out looking for a job. I'm trained in line boring and welding, because I mean it's a need. There's
yeah.
a need for it.
When you come down here, I can link you up with some schools and stuff. I mean, that'd be awesome. That'd be something that
Yeah.
I as a welding instructor, I would have been interested in when I was doing that.
Yep. No, I'd be happy
And
to.
I mean, like the amount of money they get for grants and all that stuff. I mean, that's a
Right.
drop in the bucket. I mean, they could set something up like that and just do like a 2 week class on it. Like you said,
Yep.
you're training people in a day. If you
Yeah.
spent like 2 weeks, I mean, everybody could rotate through and get
Yeah.
exposure to it at least.
Right. Right.
Yeah,
Yep.
it's definitely a niche market where I mean, you can
Mhm.
get in there and you can make a lot of money doing that stuff. Like you
For
said,
sure.
you really only need to work 3 days a week. But I mean, hell, if you could line it up, work 5, 6, 7 days, especially a young kid coming out of school getting into it.
Yeah.
And I mean,
Yeah.
there's not a whole lot of risk associated with it because you're working on a
Right.
stationary part.
Right. Right. Yeah. I mean, what business can you think of where you can spend 25, 30,000 and have this potential return of easy six figures, no time, no problem at all. You go to college, you're going to spend more than that for 1 year of school.
In one term,
And
yeah.
you know what I'm saying? I mean, and then you might not get a job no matter what.
Exactly.
Yeah.
Got a degree in gender studies. How's that working out for you?
Yeah. Oh gosh.
Yeah, no, it's a pretty cool system, man. I really appreciate you coming out here to the show and kind of explaining
Yeah.
and walking everybody through it. And I look forward to having you out here for the section meeting, hopefully November, December timeframe.
Absolutely.
We'll get a
Yeah.
date locked in and hit it.
Yep. Just give me some dates and we'll make it happen.
Okay. Well, if anybody's interested in getting this equipment or, like learning more about line boring, where can they go?
Yep. So our website is borerepair.com, and that has a link to our Instagram page, and you can see all sorts of videos and photos of real life jobs that this equipment is being used on and has been used on. And again, that address on Instagram is bore_welding_line_boring.
Oh, very cool, man. Eric, I
Yeah.
appreciate you coming out here and, like I said, taking the time out of your evening to educate us on line boring.
My pleasure, Jason. Thank you very much for having me.
Thank you.
You bet.
All right, ladies and gentlemen, thank you so much for tuning into this week's episode. Be sure to tune in every Monday for new episodes of the Arc Junkies podcast and the first Wednesday of every month for new episodes of Weld Wednesdays with AWS. Please give the show a review on Spotify or iTunes if you have a moment, and share the show with anyone who's passionate about welding. Hope you all have an awesome week. Stay safe out there, and until next time, make every weld better than your last.